Hi everyone, in this video today I'm going to look at the chain rule, which is a special rule that we have for differentiating. This is used specifically when we have a function inside another function, so as I've said here, that's like f of g of x. It's those composite functions where we can identify an inner function and an outer function. There are two different ways to write this rule. Okay, this first way I think is just generally nasty. I tend to not really use that. I much prefer the second way of writing it using the Leibniz notation. So this one here, dy dx is equal to dy du by du dx. That little dot just means times. Okay, and this is a really nice one to remember because essentially it's a little bit like the du's are cancelling each other out, even though they don't. That's kind of what it's suggesting. So if we have a look at these, we will see how they can be used. I don't know what's going on here, just give me a second. There we are, that's better. Okay, so there is, let's just go through this. So start off with, we need to bring in some kind of u into this. So we always make u the inner function, okay? Let u in this case equal x cubed minus x squared. And based on that I can say that du dx, so differentiating u with respect to x, will leave 3x squared minus 2x. If u is equal to that, then what I can actually say is y is equal to u to the power of 4, just by making that substitution in here. So from that I can now get dy du by differentiating y with respect to u, and that is 4u to the power of 3. The next thing I'm going to do is rewrite the rule, so dy dx is equal to dy du by du dx. And substituting those in, we have 4u cubed multiplied by 3x squared minus 2x. All I need to do now is replace that u with what it was originally, so it is 4 bracket x cubed minus x squared to the power of 3, and then that is multiplied by 3x squared minus 2x. Right, sorry about that. So the thing is that there is actually an easier way to do this, and if we have y equals x cubed minus x squared to the power of 4, what we can do is we can actually just differentiate this as we would like anything else and then multiply by the derivative of what's inside. So this is a bit of a shortcut, okay? Dy dx equals, now it's going to be 4 times all that cubed, and then I just need to multiply by the derivative of what's inside there, which is 3x squared minus 2x. And if we just have a quick look, those two answers are actually the same. So there is an easy way to do it, but I really recommend knowing the longer way of doing it, because you sometimes get like functions inside of functions inside of functions, and it just gets really messy. It's important to have a strategy for working through them. Just have a quick look at this one here. So the inner function in this case is what's in the denominator there. I'll say let y equal f of x to start off with, and let u equal 2x squared plus 1. So based on that, du dx is going to be just 4x. And I can say that y is equal to 5 divided by u, which is the same as 5u to the power of negative 1. So differentiating that, I get dy du is equal to negative 5u to the power of negative 2. Writing out the rule, dy dx equals dy du by du dx. Making the substitutions now, I've got negative 5u to the negative 2 multiplied by 4x. So that is negative 20x, and then u to the power of negative 2 means it's going to be over u squared, and u was 2x squared plus 1, and that has to be squared. Anyway, I'll leave it there. See you later.